All right. There you go. There's our audio. I apologize for the audio. It's weird. Different modes here. They change anything. As you guys can see, I could actually ban people. And I actually have, yeah. I won't go into those stories. I don't want to digress. But I don't know, maybe you guys know, some of you guys probably through the pandemic, you guys remember the pandemic and you were probably on Zoom and everything. Were people kind of insane on Zoom? Did you guys ever see that? No? Good for you. You guys never seen that kind of stuff? Good for you. I did. So I had to ban people that were banned. Anyway, so this has an ability to ban. So I got to be careful because it's like you touch it and it's like, what happened? You have to cancel that. So there's things you touch, old man time. So, all right. So what are we looking at here? So let you guys know, ladies and gentlemen, we're going to transition here to this topic known as proof. Proof. Now, you might say, Mr. Judge, why in the world do you need to study proof and all these relationships that exist between, really specifically for this class, it's a trig class. Why do we study proof, right? And to give you the shortest answer is because without this, more complicated relationships could not be simplified. And you're going, what? The whole idea really behind proof is to simplify relationships. Now, the question I'm going to say to you here is, what things do we prove? You see, ladies and gentlemen, math is not about number crunching, ironically. People go, oh, that math, that algebra is math, trig is math, geometry is math, calculus is math. In some sense, no. In some sense. What math really is about this word called what? Proof. Has anybody ever seen a proof or worked on a proof before in your life? Anyone? Where have you seen the word proof? Where did you guys have to prove? Right? Anybody? You've seen proof? You've heard that word? Where have you seen it? Where have you used it? Well, we've done some proofs, yeah. You see, all of these ideas that we work with just didn't fall out of the sky. And oh, guess what? There's this thing. Yeah, we've done some proof here. Because all of the stuff that we've done really comes from that idea called proof. You may not think of that, but you go, really? We can prove things? Yes, proof. See, without it, and this is what makes math unique, our facts, our relationships are what's called valid. Valid means what? Your conclusions are inescapable from your assumptions. And that's very different from any other topic. So you might say, really? Yeah, well, typically you might have said back in geometry, they give you these kind of things. If triangle, then square. Do you guys know what I'm talking about? And in geometry, you had this column that was, oh, you're given an assumption, and you had to prove the conclusion. You guys remember that? And this was kind of the structure behind geometry. So this was the assumption, if you guys remember from geometry. You guys remember that? This is what you assume, and then this is what you what? This is called the conclusion. Okay? And what you're looking at is what's known as a conditional. If something, then something else. Now, what I said to you guys earlier here, this is a proof, in geometry where your conclusion is inescapable from your assumption. That made it valid. So this is from the world of geometry. Probably, again, ancient information. Geometry is ancient. Those facts that we work on in geometry that describe the world around you is ancient. Huh? What's that? What's that? Yeah. Yeah. I mean, a lot of what we work on is man has been working on this for thousands of years. It's led to innovation. It's led to everything that's in your phone. You without these kind of statements and proof, you don't have any innovation. None. Do you guys know what I mean? You go, what are you talking about? Well, you live in a technology age. You guys actually remember programming isn't somebody taking, who's taking Python again? Good for you. Good for you. Python. Absolutely. This is your age, ladies and gentlemen. This is your time. And I highly encourage you to definitely do those things without a doubt. I'm even taking a Python course myself right now, a self-paced one. So, but don't ask me Python questions because I haven't started. Well, like for example, our facts are all valid. They're all valid. What do you mean? I say, what do you mean by that? We prove them. Our conclusions are inescapable from the assumptions. And you might say, what does that have to do with programming? Well, when you program, ladies and gentlemen, the language you use, all these ideas, the conditionals there in programming, they're all there because programming languages came from mathematics. The topic that people say nobody needs. It's not useful. There's an agenda there, folks. It's probably the most useful topic you'll ever have in your life. And it's responsible for innovation. So if you're even looking at the technology I'm using right now, it's all written on programs. Technology in this room is all written on programs. Somebody wrote that stuff. And they use mathematics and logic to do it. This is what they used. It wouldn't be here without it. So the kind of things we prove, though, and back to my original question, right? The things we prove in a trig course are what's called identities. Okay? So here's the answer to our question here. All right? It's called an identity here. Now, ladies and gentlemen, let's do some more here, okay? You say, really? We prove identities? I'll say to you now, here's the next question. What is an identity anyway? You might say, I don't know what an identity is. An identity, ladies and gentlemen, differs from an equation. So you might say, what do you mean? Well, let me give you guys a note. You may have an equation, something like this. If it says 2x equals 6. Okay, 2x equals 6. And of course, what they ask you for an equation is, what is x? What is x? So you guys tell me, what is that value of x? Another ancient situation kind of thing. People have solved this. In fact, I think on the pyramids, in Egypt, you guys don't know, algebra has existed in Egypt. The Egyptians, when they built the pyramid, were working on algebra equations when they built their pyramids. So it's found, algebra is actually found written on leaves. Not even on paper, but leaves somehow. Algebra, quadratic equations, solving quadratics. Like I told you guys, the knowledge is ancient. So what is x? Do you guys know what the value of x is? 3. You say, how do I know it's 3? Well, you have ways you can solve. You can guess. You can say, 2 times some number is 6. That number has to be 3. Sometimes people guess, or sometimes you just use techniques to what? To solve. So we got the value of x being 3. Now that's an equation. You say, well, what's an identity? Well, I want to give you guys another note. What if I told you x is -2? Does that solve your equation? Do we still preserve this equality? Is it going to be equal, ladies and gentlemen, if I use the x value being -2? The answer is no. So when I plug in x being +3, I get what's called a true statement. Is that right? If I plug in x being -2, I get a what? A false statement. You guys okay with that? Does that make some sense? What's an identity? An identity is true, ladies and gentlemen, for any value of x. That's the difference between an equation and an identity. It's true for any value of what? X. And so that's what we're about to engage in, the process of proof. And we prove what's called identities, meaning you could use any value of x and it's going to be true. Like you have what's called a reciprocal identity for secant. And you go, what do you mean secant? Yeah, secant is a reciprocal of what? Of cosine. So what that means is if I plug in an x value, for example, and that x value can be an angle. If I plug in 30 degrees here and 30 degrees here, ladies and gentlemen, if x equals 30 degrees, what do I know? You get a true statement. If x equals 45 degrees, what do I know? I get a what? True statement, okay? In fact, I can plug in any value of x, and I will get a what? True statement. Okay, that's the difference between an equation and an identity. Okay, equations are specific. They're only true for maybe one or more values. If it's a quadratic, for 2 values. But for identities, any value of x makes that true. And that's what we're going to work with. Identities, we got to prove them. So when you say, what do you mean by proof? Well, here's the thing. We're going to represent our identities this way. Okay? Identities are going to look very much like equations. And what we're going to ask you is the following here. Okay? Here's the real issue. We have to show the left hand side equals the what? Right hand what? Side. We have to show this. So you might say, well, what does that mean here? The left-hand side, is this the left-hand side? You guys okay with that? We're going to show the left-hand side equals the what? Right-hand side. And maybe we shouldn't use colors that are similar. Maybe we use colors that are very different. Left-hand side, there is your left, equals the what? Right-hand side. This is what we're going to need to show. So here's the process, and then here's the idea. Now, I'm going to get an example, but we're going to use some facts here. So let me just say, by the way, I'm going to say, by the way, how do we do this? How do we actually do some of that stuff? you're going to have to use logic. And you go, logic? Yeah, I'm going to show you the logic. So we're going to use logic and really algebra, also known as arithmetic. So to show the left-hand side equals the right-hand side, we're going to use logic and arithmetic, ladies and gentlemen. Now, let me start off with some fundamental ideas behind logic, because it's really simple, okay? And this logic is everywhere in math and philosophy. It's actually everywhere in life, but people don't really realize that. So let me ask you guys a question here, logically speaking. I'm going to give you guys a couple of statements here, right? Do you guys know this? If I say A equals B, and I'm going to write this as a conditional, okay? If A equals B, then what do you know? B equals A. Let me get something really quick. Hold on. All right. This is called a symmetric property, by the way. Now, you know what I do to share with people this statement? Remember, I like to tell you guys, language is really behind a lot of the logic in the algebra. Language. So this is going to kind of date me, but all right. Here's my first example. I'm going to prove this to you guys, right? Jennifer Lopez is J-Lo. Is that true? You guys know Jennifer Lopez is who? Is she J-Lo? Okay. You see that word is? You know what that's code for? Equals. So Jennifer Lopez is J-Lo. If I can say that, what else can I say? J-Lo is who? Jennifer what? Lopez. The left, J-Lo. The right, who's that? Sorry. The left is Jennifer Lopez. The right is J-Lo. Can I switch this statement and it's still valid? Is that right? That's like, this is a symmetric property in logic. Okay. Is that kind of easy? What do you guys think? Is that pretty simple? That's easy. Is that right? Let me give you guys another property that you guys want to be aware of. If A equals B and B equals C, then do you guys know what I can say? What can we say? Huh? Well, we can say A equals what? C. Now you might say, what do you mean by that? That's called a transitive property. I guess, was I writing it? Yeah, transitive. And I guess if we want to be with their colors, right? So you guys can see that. Here's A, and I guess we're saying this is B, green, right? Here's green, and then let's bring out that purple. And you go, well, what does that look like? A and what? There's some logic. Now, what am I going to go to? Jennifer what? Lopez. So if I said to you guys, if Jennifer Lopez is who? J-Lo. If. And what else do you guys know? Jennifer Lopez is who? Jenny from the Block. Let me see if I wrote it the way Jennifer Lopez is J-Lo. Oh, no, we have to write it this way. J-Lo is who? Jenny from the Block. We'll write it that way. I apologize. Let's write it where it's the same. Then what can you conclude? Then what can we say? Do you guys know? Jennifer Lopez is J-Lo, and J-Lo is Jenny from the Block. Jennifer Lopez is who? Jenny from the Block. Because the word is in English, that's short for is equal to, is the same as. So we can say Jennifer Lopez is Jenny from the Block. Easy peasy lemon squeezy. Okay, you guys okay with that? Is that kind of simple? Okay, simple logic there. So we're going to use some of this simple logic, and then we're going to also use some arithmetic or algebra because it's going to be the same thing, you know. And we're going to prove the left-hand side equals the right-hand side. You go, what do you mean we're going to prove that? Yeah, we're going to follow these guidelines, okay? So here's going to be our guidelines to proof. So your book actually says all that. We're going to say we're going to start really with one side. I really start with the left side, but we'll give you the book's interpretation. Start with one side, and they want you to start with the easier side. Start with one side of the equation, okay? And write it down. You're going to do the following. You're going to use what's called known identities. Known identities. You're going to use that. And algebra, arithmetic. To change the side you started with. Okay? And I'll finish that statement. You started with to the other side. Question 3. This is if you get in trouble and you say, I'm in trouble, I'm in trouble. Well, if you're in trouble, I'll put the word trouble. You can convert, that's if it's stuck. You can convert, and it may be helpful. The functions to sines and cosines. Okay, so those are the kind of things you do if you get in trouble. Okay. Now, go back to this statement right up here, and I'm going to find that. We're going to say, okay, use known identities. What are the identities that you guys actually already know? Do you guys know? What are some known identities here? So let's talk about that. Known identities. We actually gave you some of these as definitions. Do you guys know what identities you already know? If I said to you, secant is what? The reciprocal of cosine, or vice versa. Maybe you want to write it that way, right? Right? Yeah, I think we did do it that way. Sorry. Secant is the reciprocal of what? Cosine. You guys remember that one? What's another one you guys know? What about cosecant? What is cosecant? Yeah, it's the reciprocal of what? Sine. Is that true? Yeah. Cotangent is the reciprocal of what? Tangent. You know what these are known as, by the way? These are called the what? Reciprocal identities. All right. Didn't we kind of look at those? Anybody have any questions on that? These are our known identities. They're the ones we're going to start with. These are in our toolbox. And also, let me share with you guys this. We have some even and what? Odd identities. What is sine of minus x? What is cosine of minus x? And what is tangent of minus x? These are known as the even and odd identities. Okay, so all these are identities, reciprocal identities, even and odd identities. Do you guys remember those? What are those identities? Trying to remember. Sine is what? What do we remember about sine? Remember working with that? It's odd. It's minus sine of x. Is that true? Do you guys remember that one? Cosine of minus x is what? It's even, so it's cosine. What about tangent? Odd. So I'm going to put the words next to them just to kind of remind you guys. But these are identities. These are some of the known identities that we've had. So this is odd, this is even, and then this is also odd. So you guys remember those? Those are some ones that we have. And then, ladies and gentlemen, we're going to have now some other famous identities you guys want to know. The Pythagorean what? Pythagorean identities. Does anybody remember these? Or did we talk about the Pythagorean identities? Maybe we didn't. Do you guys know what they are? Let me do this. Maybe we don't know. Let's do it this way. Do you guys know that sine squared, I'm going to use theta, sine squared theta, we can change or a letter. It could be theta. It could be x. I'm going to use theta for a good reason. Sine squared theta plus cosine squared theta equals 1. Do we know this? Because if we don't, we'll learn it. Huh? Do you know about that one? Maybe we don't. Okay. So here's what I'm going to do then. Okay, let me go to my website for you guys here. And God, this bothers me, putting that little thing there. Why does it have to be in front? Yeah, that little tab. Let's go to 241. No, I'm going to go to, I believe we're going to go back to our circular functions, because if we don't know that, I'm going to show it to you guys. I'm going to prove it to you guys. Okay, so geometry, circular functions. Where are you? There you are. No, maybe I was on the first one. Okay. Boy, it takes a long time to bring down here. Okay. Remember this? This is the unit circle on circular functions. So you go, okay, x squared plus y squared is 1. Do you guys remember that? Okay. Now, x squared plus y squared is 1. I'm going to write that down on the iPad. And that comes from our unit circle. And then what am I going to do? Go down here. What's the definition of bicircular functions? What's the definition of cosine theta? Wasn't that the x coordinate, ladies and gentlemen? Okay. What was the definition of sine? Wasn't that the y coordinate on the unit circle? Double check. That comes from our definitions, right? So if I go now here to the iPad, and I'm going to prove that to you guys. Okay, you know what I get to do here? Focus on this. Can I square both sides of cosine? Or how about if I do this? I could do a couple of things here. I want you guys to see that. Don't look at that. What if I substitute? Do you guys know, what does it mean to substitute? I'm going to plug in this x value right here. My x value is going to go right in here. What does that give you? That means instead of x, I have cosine squared theta. Is that right? Maybe I'm going to use the other colors again. So I'm going to substitute, plug in, right? If x is cosine, so plug that in. What is y? Y is sine. I plug that in here. So what I'm saying is this is plus sine squared theta, and then what does this equal? 1. You know what I just did for you guys here? I demonstrated, I proved to you your first Pythagorean identity. You guys want to know that identity like you know your name. This shows up in math and science for ever. Cosine squared theta plus sine squared theta equals what? 1. Anybody have a 1-year-old child? Anybody? What can I say? If I were to build a candle, if I were to make a candle for her first birthday, I'm going to sell this candle. Cosine squared theta plus sine squared theta. Put it on the cake. I'm going to do this. This is my business. Cosine squared theta plus sine squared theta. I'm going to make that math candle. And you can put it on a birthday cake for a 1-year-old. Think people are going to know? Hopefully. That's equal to the number what? 1. I just substituted. This is your first what? Pythagorean identity. You guys want to know that one. There's two others. So you say, what are the others now, right? Well, I'm going to demonstrate to you guys some mathematics here to generate those others here. This stuff just does not come out of the what? Sky. I'm going to divide both sides, ladies and gentlemen, by cosine squared theta. Well, you know what I could do? No, I'm not going to do that yet. I'm not going to do that yet. Am I going to do that? Here's what I'm probably going to do. Since cosine x, or cosine theta is what? X. I'm going to do a couple of things. I could demonstrate this to you guys. What would you guys say? What's 1 over x? Doesn't that mean 1 over x is 1 over what? Cosine theta. Or we can say 1 over x is really what? Secant theta. Is that true? Because what is 1 over cosine theta? Isn't that secant theta? And then let's put all of this over here. Okay. We'll use circular functions. If sine theta is y, 1 over y is 1 over sine theta. Is that right? And what's 1 over sine theta? I think that's cosecant theta. Is that right? And another circular function they gave us was that tangent theta was y over x. So this is all based on the circular functions here, okay? Definition of circular functions. And then, so do you know what that means then? This means here, by using some of that same logic I shared with you guys, that tangent theta is y. That is what? Sine theta over what? Over cosine theta. Because if you need to see colors, maybe I don't want to use those same colors, but right? Because y by circular function is sine theta. Remember? This is the y value, and then this is the x value. Sine over cosine. That's your tangent. Yeah. Now you say, well, that's not a Pythagorean identity. Okay. Is it true then? Let's see, what could we do here? Let's go back to this algebra. There's a lot of ways I can do this for you guys. If x squared plus y squared is 1, okay, I'm going to divide. I'm going to use a little bit of algebra. Both sides by x squared. So on the left side, we get x squared over x squared plus y squared over x squared. It's just simply 1 over x squared. Right? So what's x squared over x squared? That's 1. And then I can write by algebra, you know, x squared, y squared over x squared is just y over x to the second power. I can say that's 1 squared. I could write this as 1 over x to the second power. You guys with me on that? Just using a little bit of that algebra. So the question's going to become this. What's y over x And then what's 1 over x? You already know what 1 over x is. What's 1 over x? Isn't this over here? And that's secant theta. So what I know here is this is going to be secant squared theta. Okay? But does anybody want to tell me what's y over x? Oh, we know what y over x is. What's y over x? We have it here. Isn't that tangent? So y over x is tangent. So we have the second what? Pythagorean identity. This is what you guys want to know. You want to know these identities, ladies and gentlemen. 1 plus tangent squared theta is secant squared theta. I use this all the time in my calculus courses. Calculus 1, 2, and 3. I use these identities all the time. Huh? Oh, I'm sorry. Cosine squared theta plus sine squared theta is 1. That's a Pythagorean identity you guys want to know. I use it all the time. 1 plus tangent squared theta equals secant squared theta. Use that identity all the time. In fact, I'm gonna say this to you guys. I'm glad you're taking trig. Do you guys know why I'm glad you're taking trig? Because if your intention is to take calculus 1, 2, or 3, trig's there. One of the biggest issues I have is that students taking calculus 1, 2, and 3, some of those students somehow skip trig. And then what happens? They have a problem. So some of my calculus students right now, we're going to do today, we're going to deal with some trig stuff. Because they're using calculus with trig in a lot more detail. They have been doing calculus with trig, and they've been using these identities. You guys see what I mean? Okay. The last Pythagorean identity. I'm going to do some more algebra. I'm going to do the same algebra I did here. Okay, I'm going to start now. Again, I'm going to start with this x squared plus y squared equals 1, the unit circle. But this time, I divide by what? Y squared to both sides. On the left, using some algebra, we're dividing both sides by y squared. So that's y squared over y squared is 1 over y squared. And so you get x squared over y squared. Y squared over y squared is 1. So you guys might say, I see where you're going with this. You're using the same algebra, beginning algebra. And I can write 1 over y squared as really 1 over y to the second power. So I'm just using some algebra here, ladies and gentlemen. So all of this kind of is a little bit, this algebra stuff is about S. Supplement. This is algebra. Now here's the deal. You might say x over y. I've never seen that before. Okay. Does anybody know? You know what y over x is. Is that right? Didn't we see earlier? Tangent, by definition of circular functions, is y over x. Is that true? Then what is the reciprocal of y over x? What happened? Anybody know what the reciprocal? What's the reciprocal of a fraction? You flip it over. So I'm flipping over what? Tangent as well. If I flip over, if I flip the left side and the right side, right? If I flip that right side over, I'm flipping the left side over. Does anybody know what 1 over tangent actually is? That's a reciprocal, right? Reciprocal of tangent is what? See if you guys know. What's that reciprocal of tangent? Do we have any reciprocal identities here? There we go. What's 1 over tangent, ladies and gentlemen? Cotangent. So this is going to be cotangent theta. Now you might say, why? Well, let's put it in pink. Pretty in pink. We should have done all of it in pink. So this identity here for you guys, another one, the last Pythagorean identity, the last one. Oh, what's 1 over y? Does anybody remember? 1 over y, we have another reciprocal somewhere, 1 over y. Here it is. What's 1 over y? It's 1 over sine. What do we say that was? Oh, here we go. Isn't that cosecant? So the reciprocal of sine is cosecant. That's 1 over y. So here's what you really want to know. In order to be successful here, ladies and gentlemen, and it's not wasted time, it's not wasted energy. What I have just done is used algebra, though, to demonstrate to you where these reciprocal identities have come from. Okay? Where reciprocal identities come from. Using algebra, this is kind of like the S portion, right? No one's asking you to prove this stuff. I just did it for you. So you got identities here. I'm going to say these are all the things that you guys want. Everything in blue. Whether you need to put them on flashcards. Everything here in blue. Even in odd identities. Whether you put them in flashcards. You can say sine squared theta plus cosine squared theta is 1, or cosine squared theta plus sine squared is 1. Doesn't matter. But everything in blue is an identity that you guys want to what? Have memorized and know. How do you do it? Put it on flashcards if you have to. I proved it to you, right? So what happens in math is this. Everything that I proved to you is valid. There's no debate. I don't think cotangent squared theta plus 1 is cosecant squared theta. No, that's now fact. That's written in stone. In fact, you're going to probably look in Egypt in the pyramids and you're going to find a Pythagorean identity there. And they're going to go, wait a minute, they knew these identities back then? I guess so. Do you guys see what I'm saying? 1 plus tangent squared theta is secant squared theta. Put that on a flashcard. Know it like you know your name. In fact, here's another one. I think I want to highlight it somewhere. Where is it? I used it. Yeah. Anyway. Reciprocal identities you want to know. Even an odd identity. Everything in blue you want to have in a flashcard. I think I used somewhere tangent theta. Oh, here we go. This is what I want to put in blue. This is very useful as well. So when I teach calculus courses, ladies and gentlemen, calculus 1, 2, and 3, yeah, they use these identities. They're designed to make things easier, not what? Harder. You may disagree. You go, no, this is harder. Well, you guys haven't taken calculus yet. You will. Did Coach teach you about these identities in calculus? Yeah. What? They didn't use any identities in calculus? Because I remember, just so you know, my daughter, she took the AP calculus stuff too in high school. And someday she came home, she goes, Dad, she'd ask me a process in calculus. How do you do this? It's like, well, you use an identity. Actually, you use an identity to change the function. Use your trig identity. Oh, okay. You see what I mean? So that information is there. It's going to be there. So I'm going to teach I'm teaching a calculus 2 class later today. And in calculus 2, guess what we're going to work with? The calculus with trigonometry. Stuff I'm going to show you guys. Imagine if you skipped it. Woo! Anybody, you guys imagine? What if you skipped it all? I don't know. Man. That's a logic I just can't get my head around. If you skipped it, you skipped all of it. It's like, well, how are you going to do it? Well, okay, now you got to learn. You know what I have to show those students? You know what I do? Where's my browser? So, okay, well, you skipped it. All right, well, guess what? I have some trig videos for you. Go back and learn how to graph secant, cosecant. Go back to learn how to, I think somewhere over here we're going to see some more. Where's the proof? Yeah. See this? This was in Halloween, ladies and gentlemen. In honor of Halloween, when I did this video. This is why it's black. It's a little goofy. I did a Halloween lecture on proof. Express sign as a single. Yeah, this stuff here too. Yep. So I have to, yeah, at least they have some videos to go back to and look at. You know what I mean? And in fact, in the calculus course, just so you guys know further, anybody go through my website, by the way, by any chance? Here's, like, for instance, Calculus 2. I have a bunch of worksheets in Calculus 2 and videos. Oh, look at this. This is some Calculus 2 stuff. They got trig integration, trig. You guys see a lot of that trig stuff? Any of these? So I do have a bunch of videos and resources there. Calculus 2. Same thing for Calculus 1. You go, oh, Mr. Judge, you have those resources for Calculus 1? Yeah. Worksheets and what? And videos. In fact, I even have notes. Notes. This is what I have to start to work on today with that Calculus 2. Polar coordinates. Where do you guys see polar coordinates? Trigonometry. This is what we'll see. You guys see? And you go, oh, am I going to take statistics? Yeah. Do I have resources on statistics? Oh, yes. Resources, ladies and gentlemen. In fact, you know how old some of these resources are, even though I've updated them? This is back when 720p was what? There's the old Mr. Judge, 720p. Not bad. 720p. I did videos. We didn't have iPads back then. All right, so I have trig resources, even now with the TI update. But I actually have a whole library of trig or statistics. And even down here, yeah, same sort of thing. This is sort of the updated version of things. This is where you have iPad stuff. All these resources for what? Trig. So I'm just working on yours here to establish some of those. Anyway. And then one day, you know what they're going to do? You ain't going to believe me on this one. You ain't going to believe me. Maybe in 2 years, you know what they're going to say? You don't have to teach trig. Just put people in calculus. Good luck. Have them go get tutoring. That's coming in a couple of years. Don't have to teach even trig. Just put them in. Let's see what happens. That's like saying that's like a unethical experiment. Imagine if you put people in calculus without even having the trig information. What'll happen? Huh? Happened to me too. So that's coming too. One day they're going to say to you, probably a couple of years, It's already in that law. Just put people in calculus who don't have any trig information. So, okay. So I guess all these videos one day are going to be gone. In fact, let me go back here. See these? I had videos on what? Look at this, Math 115. This is back 720p. Beginning algebra. Look at that, ladies and gentlemen. I had all these. I used to teach beginning algebra. Woo, everything you need. Beginning algebra. Even my students would say, can I have my younger brother and sister watch that? I go, sure. It's all free online. Beginning algebra is there. And 125 is there. Oops, not that. Same thing. So one day, some of these videos, all of that's going to be gone. Anyway, I'll keep it up. I'll leave it there. I actually pay for it. I pay for my own website. Huh? I don't remember. Huh? I think it's like a 2-year thing or 3-year. You know, you got to have your own domain name, so you guys know. And you might say, why did you do this? Because you didn't, believe it or not, you know, when I did this stuff originally, I'll share that with you guys. I'm digressing. Don't worry. Here's originally when it started. I kept this up. I wrote this in 2007. This is the old website. So we used to stream this from campus. So I have some of the old, I kept it up just for this. I had my own server on campus. And, you know, so this was some of the old, in 2007, I wrote that. You guys were born in 2007? Yo, Mr. Judge, I was born in 2007. Huh? You were 3. Well, I wrote this when you were 3. I knew you were going to be here one day. And I wrote that and had my own server from campus and streaming server, multimedia, video library. And what happened is that the school came to me and said, you know what? You're taking up too much bandwidth, because at that time, the whole world was sort of watching this stuff. I used to get email from people all over the world back then saying, thank you for putting this online. You guys want to hear a funny story? Here's a funny story. I got an email from somebody from England, and they said, finally somebody teaching math who speaks English. And I'm like, that's from England. What do they speak in England? And this is East LA English. Isn't that kind of funny? I thought that was funny. It's weird. It's like, what are you talking about? Yeah, and then whole schools back then were using this video library for like their nursing school. So do you mind if we use this for our nursing school? I said, sure, go ahead. I had another school somewhere say, from psychology, do you mind if I use your, it's kind of interesting. They asked permission and they didn't have to because it's online for free, but they still asked permission. No, you can do it. I once had a girl contacted me. I guess I can't tell you guys this story. I can. You guys are adults. Are you guys adults? I had a lady contact me. She says, I seen your videos. I live in St. Louis. I want to fly out to LA and meet you. I said, oh, shoot, nope. I got a stalker. Got a stalker from St. Louis. Isn't that crazy? That's scary. That was terrifying. I was terrified. She even sent me a picture. I was like, oh, no. I'm like, oh no, I didn't even respond. I didn't want her to find me. I thought that was funny. I know it's a funny story, but so all these resources there. So, ladies and gentlemen, again, and I'll tell you another quick story. I even recorded videos and made recorded videos for pre-calc. No, I'm sorry, for pre-algebra. And the problem with those videos is they were all out of focus. The camera, for some reason, did this all out of focus. So I have a bunch of pre-algebra videos that was going to be here. Because they used to teach pre-algebra too. Because students needed pre-algebra skills. They needed all these skills. I even started, and I think college algebra was somewhere too. I got college algebra videos, but anyway. Yeah, some of these from college algebra, some of these, not all. Anyway, so there's some resources there, ladies and gentlemen. They're free for you guys to use if and when you need them. Okay, still working on the trig stuff. But harder and harder to do. Okay. Let's take a look at something here so we can get started, okay? I'm going to share with you guys how to do this. Let's go. Try this out. It's crazy, huh? St. Louis, want to meet you? Yeah. Huh? Okay. Here's going to be your first proof. And you're going to do this process over and over again. Cosine theta cosecant theta equals cotangent theta. Okay? Now, the left-hand side equals the what? Right-hand side. Left-hand side is the same as the right-hand side. We're going to have to prove this identity. Now, here's the key. Here's what you guys want to do. Here's what you always do. You're going to start with the more complicated side. So you might say, what's the more complicated side? What do you think they mean by that, more complicated? I kind of look at it and say, you know what? I think the left-hand side is more complicated because there's two functions, and what's going on with them? Multiplying. So you're going to write this down. The left-hand side equals what? Cosine theta, cosecant theta. That's how you guys start. And that is important to do. Start with what? More complicated side. So you're my left-hand side, and isn't that true? I'm just saying to you that here is my left-hand side, right? Okay. That's all. And what do you think I have to show? I'm going to have to show that left-hand side, and I'm going to write it down here. We're going to show the left-hand side equals the what? The right-hand side. Show the left-hand side equals the right-hand side. Now you might say, how do you do that? Do you guys know how you do it? Let me put some more notes. You're going to, again, I already put it down. You're going to use what? Known identities in algebra. So remember I said to you guys, you want to memorize and know those what? Known identities, right? All the ones in blue. You know what I'm going to point out to you guys? What do you think? Do you guys know what cosecant theta is? What's cosecant theta as a known identity? 1 over what? Sine. Is that true? That's right. Okay. You guys with me on this one? That's why you want to know those identities. So you're going to put it on flashcards. That's kind of helped me. And then you say, what happens now? Well, what happens now is you're going to use that algebra or arithmetic. So now this is the algebra part or arithmetic. The reason I say now, do you guys remember from algebra? I'm going to do this to you guys. See if you guys remember. This is what I mean by algebra or arithmetic. How do you guys multiply fractions? This is the algebra in purple. Do you guys remember how you do it? Yes. Yes. Horizontal cross. And then that equals what? A times C over what? B times D. So using the algebra, what does that mean? Saying cosine theta times 1 over what? 1 times sine theta. Now, if you already know that it's cosine theta over what? Sine theta, then you could just go there and say, I know this is cosine theta divided by sine theta. Does anybody know what you're looking at here? Now, I apologize to you guys. Do I have it? I don't think I have it. I have tangent theta is sine over cosine theta. I'm going to add another one to memorize to the list. Let's think. Do you guys want to think? Let's think. If you know tangent theta is sine over cosine, what's cotangent? Aren't these reciprocal? What's a reciprocal? When you flip a fraction over? So what is cotangent theta? Cosine over what? Sine. Add this in blue to the list. Okay? Add it to the list. You guys want to memorize that. Cotangent theta is the reciprocal of tangent. So flip the fraction over. That's cosine over what? Sine. Okay, you guys okay with that one? What do you think? Okay? Now, guess what, ladies and gentlemen? What's on the right-hand side? Cotangent theta? Oh, okay. So what can we say? This equals what? Cotangent theta. Isn't that the what? Right-hand side. Ladies and gentlemen, you've shown what? The left-hand side is equal to the what? Right-hand side. You have proven the identity right here. You're done. That's the process. Is that difficult? Well, you need known what? Facts. Now, let me say this to you guys. Even though Even though, by the way, if we go back to my website here, 241, see browser. 241, browser. Where are you? I have a trig cheat sheet. What I have used here for students on exams, I let them use a trig cheat sheet, right? What do you guys see here? On the left, what do you guys see? Tangent, cotangent identities, reciprocal identities, Pythagorean identities, and even and odd identities. So even though I let you guys use them, what I still have to say to you is I think the best thing you should ever do in your life is memorize them so that you can use them more efficiently. Because if you're going to keep looking back at this sheet and go, oh, what is cosecant? And you spend 5 or 10 minutes trying to figure out cosecant being 1 over sine, that's not good. You guys see what I'm saying? It ain't good. If you say, what is sine squared theta plus cosine squared theta? You spend 5 or 10 minutes trying to think about it and even looking for it. It's not good. What is better, more effective, is to memorize these what? These identities I gave you guys in blue today. That's the best approach. So we did a little bit of algebra today as an S situation, but nevertheless, you're going to be using that. We're going to use known identities. Let's change that color. Combined with what? Algebra, or I really say arithmetic, because algebra is arithmetic in some sense. It's the same kind of, process. You can do that with numbers and what? Letters. Okay? Like cosine theta times 1 times sine theta, 1 times anything is itself. That's what I mean. But this is the same algorithm over here on the left, the algebra algorithm that's done for multiplying fractions or multiplying what's called rationals. And these are rational-ish. They're not exactly rationals, but they're the same. I can call them rationals, sort of. Fractions. That's all. So multiplying fractions. And, this is your first proof, but we're going to dive into this process. Okay? And when do you guys want to get started? Huh? When do you guys think it's a good time to get started on this stuff? The night before a test? I would say no, you never do. What do you do the night before a test? You sleep. You sleep the night before. Get your rest because you're going to use your brain in the morning. Okay, that's how you do it. But before you sleep, do some review. As you guys can see on if I go to the browser here, we just started this section, 1 to 49. Some of you guys maybe want to get started now, and that's okay if you do. Get started on it. Take a look at it. We'll do some more. You go, well, what if I want to see some more examples because I can't wait till tomorrow? Good for you. Then go to where? Go to the website that says the word proof. Where is the proof one? Oh, we passed it. It's the Halloween one. I gotta change that. I gotta fix it. The one in Halloween. And I gotta go back and redo the word proof there. Profs! I don't know what happened. I didn't have my coffee. So I gotta change that. See, old man stuff. Proof. J-Lo is Jennifer Lopez. Jennifer Lopez is J-Lo. Then we can say the following. So if you want to see more examples before tomorrow, you're certainly welcome. All right, what do you guys think? Is this going to be impossible, you think? I don't think so. Is it going to be useful? Very useful. And then you guys are going to be able to take calculus and, all is well. And take it now, your trig course, before they take it away, because they're going to want to take it away. They're going to put you in a situation, so what? You make a choice. Do non-STEM? They're going to make you choose between STEM and non-STEM. That's really going to be what happens. Only the elite will do STEM and the non-elite does non-STEM. That's how it's going to work. It's the truth. Next Wednesday, I'll let you guys know in on it. I'm going to Sacramento to lobby legislators about education. Not tomorrow. Next week. Today, what's today? Yeah, next Wednesday. No. Just one day. I got to fly. I'm going to take a 6 a.m. flight to Sacramento and then visit the legislators for 6 hours, come back home on another flight at around 7 p.m. I'm just spending the day. I'm not sleeping there. So I'm going to miss Wednesday. Maybe I'll send you guys some stuff to read so you guys can be aware and, be knowledgeable. Okay, so it's not the whole week, only on Wednesday. So Mr. Judge is going out there and he's going to lecture the legislators just like he lectures you. And hopefully, there'll be some change, but oh, I'm sorry, Tiffany. Maybe you could look at the video. I'm sorry, I couldn't see that. Okay, we'll see you guys tomorrow. Take care, stay safe, and have a wonderful day.